So I'm Bill Pilaud, I'm the Director of System Architecture. Dean Holman likes to introduce me to everybody. He says, I know everybody. And I guess the reason why I know everybody is I've worked for everybody. So I had 30-year tenure starting from Motorola, Curtiss-Wright, Mercury Computer Systems, you name it, most of the board industry, including Vicor. I've been a child of this industry, grew up in it, and I'm deeply appreciative of the VITA consortium. Had it with Jing and Dean now, and started with Jerry and the other gentleman, I can't remember, Ray. And we're standing on the shoulders of giants, so really do appreciate it. Just want to give that shout out. Let's start off with LCR. We're a small enclosure manufacturer in Pennsylvania. We've been, in our charts, we say we're 37 years old, but we bought a company that's 60 years. And we've been building enclosures for the military, aerospace, defense industry for that much time, and have the pedigree with many, many large programs and people, good people and very competent. And one weakness we do have is that we're not well known, so that's why we're doing these outreaches and discussions to show you that we are part of this industry. And one of the things that is common in our industry, and it's very important to all of us, is it's a make versus buy situation. So what does LCR provide that our customers can't do? And that is speed, or time to theater. So it's always kind of a moving target with the military, because they are moving applications and platforms. We have standards like VITA and SOSA and MOSA to help us accelerate that design process. But it's always kind of moving that advancement and the board providers that we provide to get this out quicker and use these standards to our advantage to make these systems viable and possible, deliverable. So it's always a game of constraints: size, heat and power, wattage per slot, weight, space limits, you name it. They're moving targets. And when you push on one too much, either costs go up, time goes up, or it becomes unviable. So what LCR is trying to do is parameterize this, make it more modular, work at finding new ways of heating and cooling, like some of the innovations here. Some of the new technologies that are coming to the forefront. 3D printing, laser sintering for those who are more technical, to allow you to additive manufacture and do these things quickly, to design exactly what you want with just powder. Although that has some constraints, we're also looking at different type of technologies, plastics, to enable this 3D printing with thermal conductivity systems, and also deploy lightweight systems. So they are coming. But it's a little bit of the future, as well as fin technology in order to increase the area to improve the thermal performance and make things that weren't viable in an ATR form factor or small form factor more viable. But still, a lot of this stuff is TBD, a little bit more in the future. We're seeing it now, it's starting. It is the wave of the future, but right now we have to design with what we have. So we always do these trade-offs with cost, lead time, complexity, size, weight, and power. And we definitely try to leverage the standards as much as possible. They give us an interface to our board partners and give us ability to communicate to our end customers. And thank God that finally that the military is recognizing that VITA and its standards are the deployment asset going into the military. It took us 20 years to get here. And I want to thank you all for the hard work that you are doing here, because it is happening. I don't do anything else but VPX VITA. That's all I've done for the last 2 years. It's the only proposals I make. It's the only thing they're buying. So that's the good news for our industry. So how do we do this? How do we make something that has all those parameters, all those complexities, all those trade-offs? And how do we make it more efficient? How do we bring this stuff quicker to the time to market? Well, we introduced modularity. We build space frames and subsystems that accommodate a backplane and I/O panel, and then we modularize the cooling technology. Put fin stock for air-cooled. You put liquid brazed chassis or enclosures on the sides, make it liquid-cooled. You put big old aluminum to make it base plate cooling. So that largely accommodates what you can provide into a military platform, especially an airborne transport rack or airborne type applications. This allows you to do what the platform has most efficiently. The next thing we do is we scale out. So by just changing the parameter, we can go from a 4 to 8, from 2 to 14 slots by just changing one piece of the software. So that's how we do it. We modularize into the software our designs to give a good, better, best type of approach to building our enclosures and allow us to scale. So that way, if you have lots of compute, lots of RF, we can accommodate you very quickly. Also with this parametric design, depending on the wattage, the thermal load, the environment, we can also increase the area of the system by making it wider, giving it more fin stock, more area to cool. So this is also parameterized, so that way the system can grow dynamically higher, lower, wider, longer to accommodate what the program needs, and therefore getting it very quickly out to the customer. So, we have some rule of thumbs about air cool, 70 watts per slot. Air flow through is another design that is there. The only criticism we have with the board industry right now is the readily available ecosystem for handling air flow through type technology. It's just not been brought up, or it's not offered as a standard buy off the shelf situation. And it's also big. It accommodates a larger dimension or pitch of 1.5 inches, and people don't want to eat up that precious compute space for cooling. But it may be necessary in the long term to accommodate the hotter processors that are coming down the pipe. They don't seem to be getting cooler, which is distressing. But we have to, as an industry, address that. And that's our next big challenge going forward from this day on. It's always been a problem, but it's getting even worse. So we also have another thing that we're improving the time to market strategy within LCR. And it starts off with development systems, but here's my favorite slide. It's a buyer's journey. They started off with a development chassis. They Meritech, which cabled the backplane, was a passive backplane, to get their system designed. And then, believe it or not, they deployed it. So they didn't even come back and respin it to a more rugged system. They deployed with Meritech because it gave the ultimate flexibility, and they could change it on the fly for different missions. So this was very good. I have another buyer's journey. That little development chassis can run off of aircraft power. You can plug it into a 400 hertz aircraft and fly it around. So the customer bought the chassis, cabled out his mission, flew the mission. They passed all the parameters. It flew, it passed, they won the program. The general came down, opened up the plane, looked in there, saw my development chassis, and says, "You lose. Your system doesn't look like it's TRL ready. It's not deployable." So the customer lost, that we lost, and it was very distressing for us and the customer that they had done everything right. We got it out there quickly. We still lost. So what we're coming up with is what we call the rugged test systems. They're a hybrid of a development chassis and a rugged system, a rugged baseline that looks well enough to pass the general sniff test, but allows you to deploy quickly in order to get to the theater quickly. So based on this parameter design, being able to scale up, scale out, and modify for different cooling type systems. We also offer rapid test systems also to get to the warfighter quickly. And then eventually we can spin them quickly to the systems. So in summary, SOSA Vita, godsend for our industry. It is the disruptive change that I've been waiting for 20 years. You know, as we manufacture our design and we get better at the cooling and modularity of the systems and we base that off those standards, we are able to offer systems quicker. And always, 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 because of the challenge of the chip industry, we have to look at innovation for cooling. It is the problem that we are seeing in the horizon. And don't take my word for it, take Dell and everybody else. They're deploying 200-watt processors that are causing issues in heating and cooling and temp and power in the industry. So we all recognize from top to bottom that that's number one going forward. And we are here to help deploy and streamline the path to innovation. So thank you very much.